Good morning. Today we're going to be working with simplifying rational expressions. When we talk about rational expressions, we're essentially talking about a fraction, more specifically a fraction that has x on the bottom. When we refer to the term expressions, wow, that's not what I meant to do there, expressions, we're not talking about equations. So we don't have an equal sign, we're not starting with an equal sign, so we're not going to finish with an x equals a number. We're going to finish with a simplified version of what we started with. So, rational expressions in large part require that we factor. So today what we're going to be doing, and when we talk about factoring, we're talking about things that multiply together to give us something. So if I have the number 36 and I want all of my factors, I want all of the numbers that multiply together to give me 36. I can start with 1 and 36. I'm going to start with 2. 36 divided by 2 is 18. 36 divided by 3 is 12. 36 divided by 4 is 9. 36 is not divisible by 5, so I'm not going to worry about that one. And then 36 is divisible by 6. So right here, once we have the same number or numbers switch. So like if I'm factoring 30, I have 1 and 30, 2 and 15, 3 and 10. It's not divisible by 4, 5 and 6. And then if I continue on to 6, I'm going to have 6 and 5. So this is a repeat of the same thing, so I'm not going to worry about the 6 and 5. But once they switch positions like that, that's how I know I have all of my factors of a number. The other thing we can factor are things with variables. So we're going to deal with that in just a minute in a couple of different types of factoring quadratics, factoring with the greatest common factor, and difference of squares. So we're going to deal with those in a few minutes. All of this is from the investigation that we did in class. So it's mostly just going to be walking through that students did on their own in class. So, as I said before, rational expressions are fractions. Simplifying a rational expression means we're reducing it to its lowest terms by dividing the numerator and denominator by a common factor. In other words, making ones and canceling out. So what we mean by making ones. Right here, we've got 20 over 35. We want to reduce that fraction. 20 can be written as 5 times 4, and 35 can be written as 5 times 7. Now, anytime we divide something by itself, it gives us the number 1. And anytime we multiply by the number 1, it doesn't change it. So we essentially, a lot of people will say cancel it out. I tend to prefer not to say cancel out, except for that it's easy to, but we're dividing it to 1. So we're dividing those out. So we split them into their factors, divide out the common factors to 1. So works with numbers as well as variables. So if we're looking at 4 over 12, both of those are divisible by 4, so that can be written as 4 times 1 over 4 times 3. 4 divided by 4 gives us 1, so we're left with 1 over 3. 30x to the 10th over 15x to the 7th. 30 over 15, that can be written as, both of those are divisible by 3 and 5 and 15, so I'm going to take 15. You can always start low. You want the greatest common factor, but if you can reduce something down and then reduce it again and reduce it again, that's fine too. So this is 15 times 2 over 15 times 1. The 15s divide out, and I'm left with 2. I'm going to go ahead and put that fraction part there, and then I'm going to deal with the x to the 10th over x to the 7th. So we did this with our exponent rules when we have 10 x's on the top, and I'm just going to do this the one time. 3, 4, 5, 6, 7, 8, 9, 10. Over 1, 2, 3, 4, 5, 6, 7. Hopefully I didn't lose count there. Then each pair of those that divides out to 1 is going to leave us with x to the 3rd on the top. So I actually don't need that to stay in a fraction because there isn't anything on the bottom. You want to be careful about that because if there is stuff left on the bottom and nothing left on the top, what you have left on the top is 1. So moving on to number 3, we have 4 times x to the third. Remember, this is quantity x to the third, so anytime these are in parentheses, it's like we're multiplying by one big thing. And then we divide by quantity x plus 3. So I'm going to go ahead and I'm going to take out those x plus 3's, and all I'm left with is 4. On number 4, x plus 7 can go, and I've got x minus 1 over x minus 4. Now, there is a temptation for people to do this and say that this equals 1/4. That is not okay. So, let's go back. The difference that we have here between something like this and something like this is we are multiplying this quantity by this quantity, dividing by this quantity, times this quantity. So outside of these parentheses, all we're doing is multiplying and dividing, so we can divide things out. Here we're subtracting, or in other cases we may be adding. And so on the top I'm subtracting, on the bottom I'm subtracting. I'm not multiplying anything on the top or the bottom, and so I can't divide things out. It doesn't work that way. And we did a vertical task that looked at why those numbers don't work out. Okay, moving on. Over x, whoop. So we need to deal with some different types of factoring. The first one is factoring binomials. So with binomials, we have 2 terms. And we want to look at our greatest common factor of those 2 terms. So, and you always, anytime you have any factoring to do, you want to check and see if there's a greatest common factor because it's going to make the rest of it a bit easier to deal with. So, first I want to look at my 20x squared minus 4x. Basically, what I want to do is I want to put this in this form. Like I want it to be something times a quantity something else. So I'm undistributing what that is, and I'm undistributing this greatest common factor. So first I want to look at 20 and 4, and I want to look at my common factors there. I'm not going to do this more than once, but you may want to write down your times table so you see the common factors. And then 4 is 1 and 4, and 2 and 2. So the greatest common factor in both of our lists is 4. So I can factor out a 4. The other thing I can factor out is this one has an x squared and this one has an x, so I can divide out a single x. So my greatest common factor with these 2 is 4x. So then I want to see what would I multiply 4x by to get that 20x squared. So that's going to give me 5x because 5 times 4 is 20, x times x is x squared. And then what do I multiply 4x by to get negative 4x? The 4x is already there, but I need it to be negative, so I'm going to have negative 1. So my factored form here is 4x times 5x minus 1. And that's just factoring out a greatest common factor. 3x minus 3. In this particular case, I can't take out an x because this one doesn't have an x. It just has a 3. The factors of 3 are 3 and 1, so you can divide out a 3 here. Whoops. 3 times x gives us 3x, and 3 times negative 1 gives us negative 3. And you can always check. Keep going back and forth on accident. If you were to multiply this out, I'd have 3x minus 3, and that's what you want. So the next one, 24 and 5, we take a look at those. 24 and 5 don't actually have a greatest common factor. 5's factors are only 1 and 5, and 24 is not divisible by 5, meaning that 5 can't go into 24 as a whole number. So the only thing I can take out, because they both have x's, is a single x. So to get 24x squared, I multiply x by 24x, and I multiply x by 5 to get 5x. And that's as far as I can go with that one. So So that's greatest common factor. We're just looking for the biggest number and or variable that we can get out of both of those terms. Like if you were to difference of squares, we kind of need to see the pattern in order to see how this works. So we can either use the box to multiply out our first factor. Here is x plus 4. Our second one here, I'm going to put on the side and multiply those out. I'm going to erase that real quick. So x times x gives me x squared. And again, I'm going to erase that because that can get confusing and messy really quick. So I got x squared. This is an area model, by the way, where I take the sides x times 4 to get 4x here, negative 4x here, and negative 16 here. So if I write all this stuff out as a whole, I'm going to get x squared minus 4x plus 4x minus 16. And what's going to happen is these two middle terms, negative 4x and positive 4x, add up to 0. So all I have left is x squared minus 16. I can also use the FOIL method. That's so coming back over here. So that is when I take the first terms and multiply those, x squared, outside terms, negative 4x, inside terms, positive 4x, and last terms, negative 16. Again, that would reduce to x squared minus 16. Whether you use the box or the FOIL method is completely up to you. Some people really like the box and some people really hate it. So, and I shouldn't say box, I should say area model. That's the more technical term for it. Okay, so seeing this pattern, hopefully, if we were to multiply all this out, I'm just going to do this one time and then we'll go the other way. X squared minus 12x plus 12x minus 144. So, whoops, that's an x. Those two add out to 0. I'm left with x squared minus 144. So all of these have this pattern where my first term in each quantity is the same and my last term is the same, but I have a plus and a minus. And that always ends up that my middle terms are going to add out to 0. So x plus 1 times x minus 1 is going to give me x squared minus 1. 3x squared, or sorry, 3x plus 7 times 3x minus 7. I'm going to multiply the first two terms. 3x times 3x is going to give me 9x squared. My middle terms, again, are going to add out to 0, so I'm just going to do 7 times negative 7, so negative 49. 4x times 4x is 16x squared. My middle terms are going to go. Always double check, though. Make sure you got a plus and a minus there, because if you don't, this doesn't work. And then negative 10 times positive 10 is negative 100. So when we recognize that our first and last term, and we're subtracting them, are perfect squares, then we can use this to factor a lot faster. You can also use what we're going to use in a moment, the box and diamond method. It's just not as simple. So x squared minus 6, x and x, square root of 6, or sorry, square root of 36 is 6. So plus and minus, so we've got that one factored. Square root of 16x squared is 4x. 4x. Square root of 100 is 10. And we got 1 plus, 1 minus. Now, as I mentioned before but didn't discuss, this is a difference of squares. That means we are subtracting. And only when we're subtracting. So if we have x squared plus 25, we can't factor out a greatest common factor, and this isn't a difference of squares, so there's nothing we can do to factor x squared plus 25. All right, so now factoring using the box and diamond technique. So this is when we have a trinomial, quadratic, x squared, x, and then a constant. We start with our first term, x squared, our last term, the constant. We take those and we multiply them, so 9x squared. Our middle term, 6x, goes on the bottom. What we're looking for are two terms that are going to that are multiply to give us 9, add to give us 6. So we always factor that top number, 1 and 9, not divisible by 2, 3 and 3. That's all of our factors of 9. So 3 and 3 add up to 6, so 3x, 3x. Put those in the empty boxes. This particular one works out to be a perfect square trinomial. If you can recognize those, that's another way to make things easier on yourself, but it's not totally necessary either. So then once I have my box filled out, I'm looking at any row or column to figure out my greatest common factor. When you have just x squared instead of like a 2x squared or a 3x squared, when your a value is 1, there's a lot of shortcuts to factoring this, and you can totally use those. I'm just showing you the whole method. So if I look at this column right here, the most I can take out of there is an x. X times x gives me x squared. X times 3 gives me 3x. On the other side, x times 3 gives me 3x, and then 3 times 3 gives me 9. You always want to double check this last one. Does this times this give you that? And it does. So my factored form here, x plus 3 times x plus 3. I'm going to do one that's not an A of 1. 3x squared, my x squared term in the lower box, negative 60 in the upper. So that gives me negative 180 x squared and negative 8x on the bottom. So I'm going to deal with the negatives in a second, but I got to factor 180, and that's going to take a while. 1 and 180, 2 and 90, 3 and 60, 4 and 45, 5 and 18? Nope, that's not right. It would be 5 and 36, I think, but I'm going to grab a calculator and make sure I am, 5 and 36. 6 and 30, 7, don't think it's divisible by 7, not by 8, so 9 and 20, 10 and 18, not by 11, about by 12, 12 and 15, I'm guessing not by 13, probably not by 14 either. Okay, so that's all my factors, because then I'm back to 15. Now I have this situation too, where this is a negative, so one of these columns, either the smaller number or the larger number, is going to be negative. If they add up to a negative, that means my bigger number is the negative one. So what I'm looking for is a pair of these that has a difference of negative 8. 10 plus negative 18 is going to give me negative 8. So 10x, negative 18x. I'm going to plop those in the boxes, doesn't matter which. It does matter that the negative stays with the 18. And then I'm going to look at my rows and columns. 3 and 10 don't have a common factor, so I can only take an x out here. 18 and 3 are both divisible by 3, so I can take out a 3x here. 3x times negative 6 gives me negative 18. X times 10 gives me 10x. And then I want to double check, does 10 times negative 6 give me negative 60? And yes, it does. So my factors here are 3x plus 10 times x minus 6. I'm going to run